Okay, in this lesson we're going to be looking at the trigonometric ratios in right triangles. And just to kind of review what those are, we're going to talk about the sine of an angle, the cosine of an angle, the tangent of an angle. In this particular case, we're going to be finding it from the perspective of S. So I'm going to arc that right there and shade this little angle in, saying this is going to be from our perspective from angle S. Now, the relationship of a sine, if I said the sine of S or the cosine of S or the tangent of S, that's the relationship between two sides in a right triangle. Okay? So the first thing I'm going to do is I'm going to label some sides. From this perspective, okay, I'm going to label this 21, which is QR, the distance from Q to R, that would be what's known as the opposite side from angle S. Okay? Right here, this side R to S, this side is right next to this angle, and we call that the adjacent side. And if you see me do a lot of problems, you'll notice I always kind of draw an arrow going across to represent the opposite side. Now the longest side, or the longest leg of any right triangle, is going to be across from the right angle, this 90-degree angle. Of course, we call that the hypotenuse. I remember that from geometry. All right, so now I've labeled my sides. I have an opposite side, I have an adjacent side, and I have a hypotenuse in relationship to this angle from this perspective. All right, these sides, these labels would change if I was going to go from angle Q, but we're working from angle S. All right. Now the sine of an angle, okay, is the relationship between the opposite side, right, opposite, to the hypotenuse. So we're going to do a ratio of the opposite side to the hypotenuse. The cosine of an angle is the relationship between the adjacent side over the hypotenuse. And man, pen's just not working as well as I wanted it to. There we go. That's better. And the tangent of angle S, all right, is going to be the relationship between the opposite side, the ratio of the opposite side in comparison to the adjacent side. Okay? So when it asks you for the sine of S, the cosine of S, or the tangent of S, that's the relationship. Okay? Now in order to find that, we have two sides, but we need to find the longest side. All right? So if we do the Pythagorean theorem, we know that we have the whole formula, I'm sure you're aware of, a squared plus b squared equals c squared. So we have 21 squared plus 7 squared equals c squared. All right, and the sum of those squares, all right, if you did that, you would get 490. All right, and so c, our hypotenuse, will equal the square root of 490. But we're not. If you can have a radical, you have to think about, can I simplify this? So we're going to break this down into factors. Do some couple of easy factors here. 49 and 10. 49 breaks down to a 7 and a 7. This breaks down to a 2 and a 5. Square roots, they look for groups of 2. You need to have 2 of them, all right, in order for it to come out, because the square root of 49 is essentially 7. So the 7 comes out of the radical, and what stays inside? The 2 times 5, which is 10. So this hypotenuse right here, we're going to label it, that distance is 7 radical 10, all right, simplified as a radical. So we're going to use this, and we're going to set this up over here. So if I were to set this up for each one of these, it says if we want the opposite side in comparison to the hypotenuse. Okay, well the opposite side is 21 and the hypotenuse is 7 radical 10. Now we're going to have to simplify this because you're not allowed to have radicals in the denominator, but we'll worry about that next. All right, let's look at our adjacent side. Our adjacent side, okay, is 7. So we're going to put 7. And our hypotenuse, once again, is 7 radical 10. And our opposite side here, for a tangent, our opposite side is 21. And our adjacent side is 7. Now of these, the easiest one to simplify, obviously, is the tangent. Okay, so the tangent, we can just simplify. That ratio is just going to be 3, and we're done. Okay, but over here, I'm going to move a little arrow. Over here, we are not allowed to keep 21 over 7 radical 10. So we're going to clean that up a bit. Obviously, 7 goes into 21 3 times. So now we have 3 over radical 10. Well, right now, what I want to teach you, if you don't already know, is we want to make sure we know how to rationalize the denominator. All right? We're going to show you a step to, it's supposed to be an E. Rationalize the denominator. Now, which means we want to have a rational number, not an irrational number. This number right here, this 10, is irrational. Okay? It's not a part of the rational number family. So we need to make it a rational number, a number that can be put in terms of a ratio. Okay? So how do we do that? Well, since that's a radical 10, all I have to do is multiply the bottom by a radical 10 and the top by a radical 10. Because essentially I'm just multiplying by the number 1. I'm just changing the way the number looks. Because a radical 10 times a radical 10, if you did it slowly, you could say, well, that's a radical 100. But wait a second, what is the square root of 100? That's actually equal to 10. So now we don't have an irrational number. We have a rational number in the denominator. Okay? So how do we multiply 3 times radical 10? Well, that's pretty easy. It's just 3. You stick the radical 10 next to it. Okay? So we have 3 radical 10 over 10, and that now is simplified. That would be the sign of S, all right, in an exact simplified form with radicals. Okay? So let's try another one. We're going to change 7 divided by 7 radical 10. Obviously, the 7's cancel out, and we're left with 1 over radical 10. Give me a little more room. So if I have 1 over radical 10, how do I do that? Well, the same way. All you got to do, multiply both the numerator and the denominator by radical 10 over 10. And we're going to do a little shortcut here. We know that radical 10 times radical 10 is eventually just becomes a 10. Just like if I said, what's the square root of happy face times the square root of happy face, that would just equal happy face. All right? So 1 times radical 10 is radical 10, and voila, you are done with that one. So you're done with the cosine of S. That's the simplified. You're done with the tangent of S. That was the easy one. That was 3. And you're done with the sine of S, which is 3 radical 10 over 10. Now, there's 3 others that you have to be aware of, all right? And these are called cosecant, secant, and cotangent, all right? So I'm going to scroll over here, and we're going to write those. We have cosecant. Now, the shortened version of cosecant is CSC, all right? And we have secant, and the shortened version of that is just SEC. And then we have cotangent. All right, and they call that COT. All right, now the cool thing about this, if I said what's the cosecant of S, and what's the secant of S, and what's the cotangent of S, all right, cosecant and sine, call them country cousins, they're just reciprocals of each other, all right? So if the sine of S was the opposite over the hypotenuse, this is going to be the relationship, or the ratio, of the, let's try this again, of the hypotenuse to the opposite side. So the secant is the reciprocal, or the inverse of cosine. So we're going to have the hypotenuse and the numerator, that length, and the adjacent side in the denominator. And I think you see the pattern here. The cotangent is going to be what? Well, it's going to be the adjacent side over the opposite side. So it's just kind of the reciprocal of it. All right? So these will probably be a lot easier. So let's think about what we had. Our hypotenuse was what? It was 7 radical 10. Our opposite side was 21. Okay? Our hypotenuse still, once again, is 7 radical 10. And our adjacent side in this problem was a 7. And our adjacent side was a 7, and our opposite side was a 21. Now this was a lot easier because all the radicals were already in the numerator, if it had one. This easily simplifies to 1/3. The 7's cancel out, and you have radical 10 over 1, which is just a radical 10. And this right here simply reduces to radical 10 over 3. Because 7/21 reduces to 1 over 3. All right? So, just remember, if you have to deal with the 6 trig ratios, not just 3, not just the 3 basics, sine, cosine, and tangent, all right? Just know that sine and cosecant are reciprocals of each other. Okay? Cosine and secant are reciprocals. And of course, tangent and cotangent are reciprocals. All right? So when you're working on your assignment, you could use this video as a reminder of how to simplify radicals, how to rationalize denominators, and also to remind yourself how to set up the 6 trig ratios. Okay? Hope this was helpful. Have a good day.